As promised, here are some examples of the even problems from the homework tonight. And for first of all, I'm going to do problem number 4. And then when you look at that picture, there's 12 terminal points in the circle. You had to do problem number 3, and problem number 3 there were less points. There were only 8 points, and they were pi over 4 apart. The problem number 4, there were 12 points, and each point was pi over 6 apart. And so the first point was at pi over 6. I'm going to do cosine first and then sine, because cosines are the x coordinates and sine are the y coordinates. And so at pi over 6, these are the coordinates at pi over 6. At pi over 3, those are the coordinates, and so those are the cosine and the sine values at pi over 3. And at pi over 2, because remember, I'm counting by pi over 6s. This is 1 pi over 6, 2 pi over 6, 3 pi over 6, but I reduced each one. And if you look at each one of these, it's the coordinates for those 12 points around the unit circle. And at this point, I would expect you to be pulling out your picture that has all the coordinate points on it and using that to help you with these problems. Eventually, you will have them memorized, so you will do this from memory. Problem number 6, it says sine of 5 pi over 6. Again, I would expect you to look on your unit circle at 5 pi over 6. Sine is asking you what is the y coordinate at 5 pi over 6, and the y coordinate at 5 pi over 6 is 1/2. Cosine of 5 pi over 6 is asking you for the x coordinate, and tangent is the sine divided by cosine, the y divided by x. And so you would have 1/2 divided by root 3 over 2, which would give you 1 over negative root 3. But we don't like to write our square roots in our denominators, and you're going to find in this section we always rationalize our denominators, so this is the same thing as negative root 3 over 3. For problem number 8, it's asking for the cosine of 5 pi over 3. Remember, cosine would be the x value at 5 pi over 3. Looking at your unit circle, that's negative 1/2. And cosine of negative 5 pi over 3. Now, negative 5 pi over 3 would be going clockwise around the circle till you got to negative 5 pi over 3. And you'll have to count your pi over 3 as going clockwise. And you'll find that the x value is positive 1/2. And cosine of 7 pi over 3, now you'd be going clockwise. You're going around a circle this way, but you're going to be counting by pi over 3s. And so if you counted all your pi over 3s till you got to 7 pi over 3, you'd be back at pi over 3. Number 10, we've got sine of 3 pi over 4, which is root 2 over 2. Sine of 5 pi over 4, because that's down in quadrant number 3, is negative root 2 over 2. And sine of 7 pi over 4 is negative root 2 over 2. So I want to make a little note here to remind you a little bit about fractions and square roots. That think about the fact that 1 over the square root of 2 is the same thing as root 2 over 2. So when we see these numbers, root 2 over 2, it's the same thing as 1 over the square root of 2. We've just rationalized the denominator. And we've found these by using Pythagorean theorem and right triangles and our ratio in our known right triangles, all that kind of stuff. But also remember that the reciprocal of the square root of 2 over 2 is the same thing as the reciprocal of 1 over the square root of 2, since these two numbers are the same. This is important so that when I'm asking for the reciprocal of root 2 over 2, really all you're going to do is flip 1 over root 2, which is just root 2. Not only that, but root 3 over 2 can be written, it'd be kind of silly to do this, but root 3 over 2 is the same thing as 3 over 2 root 3. And the only reason I say that is because we're going to be dealing with some reciprocals. And when I ask for the reciprocal of root 3 over 2, it's asking for the same thing as the reciprocal of 3 over 2 root 3. And now you've put the radical in the denominator so that when you do the reciprocal, you're going to get 2 root 3 over 3. And so these are just things to remember about numbers, because let's look at this problem here. If I asked you for the cosecant of negative pi over 4, which does happen to be one of your homework problems, the cosecant is a reciprocal function. It's the reciprocal of sine. So when I'm asking for the cosecant of negative pi over 4, I'm really asking for the reciprocal of sine of negative pi over 4. And sine, and so that's another way to write it. And sine of negative pi over 4 is negative root 2 over 2. So saying the reciprocal of sine pi over negative pi over 4 is also saying the reciprocal of negative root 2 over 2, which we just determined was root 2. So we've got negative root 2. In problem number, you were assigned numbers 41, I think. Yeah, 41 and 43. And so you're to look at this circle. I took a picture out of the book so I could post it here. And I'm going to do number 40, and it says cosine of 0.8. Well, the 0.8 is the length of this radius. So I'm going to look on here, and I'm going to try to find where 0.8 is. If this is 1, if you count these are tenths. So 0.8 is right here. And so, and remember cosine are the x's. So I'm looking at where the t right here is 0.8, and I want to know what is the number on the x-axis, or what we'll call the cosine axes. And if you look at that, kind of, if you can zoom your computer in or whatever, it looks to be about 0.7, because these are also tenths here, and it looks like it's just about 0.7. You're told on this problem to also do it on the calculator. So you're going to take your calculator out, but you've got to change the mode on your calculator to radians. So make sure you've done that. And then you're going to type in your calculator cosine of 0.8 once it's in radian mode. And when you do, you're going to get 0.69671. And wow, that's pretty close, because this rounds to about 0.7. So this was a pretty close estimate for what it is by looking at the circle. Another even problem I'm going to do is number 66, which is very much like your 67. And it says find all the trigonometric values knowing that cosine t is negative 4/5. Well, I need to know both the x and the y coordinates so that I can find all my trigonometric values. And so remembering that I've got x squared plus y squared equals 1, and that cosine is your x, plugging it in, I'm going to solve for my y, and I get y as 3/5, but this is quadrant 3. It's what it said up here was quadrant 3. And in quadrant 3, both the x and the y are negative. So the terminal point is this point here. It's negative 4/5, negative 3/5. So this question up here, saying find all the trigonometric values knowing this in quadrant 3, is the same thing as saying what are all the trigonometric values for this terminal point. And so if I'm going to look for those, I'm going to start off with the first 3 that we've learned about: sine, cosine, and tangent. And remember that sine is the y, cosine is the x, and tangent is sine divided by cosine, so it's the y divided by the x. And so we get those 3 values. Then I'm going to do their partners, which are their reciprocals. So what I'm going to do here is I'm going to find the reciprocal of tangent, and that's cotangent, the reciprocal of cosine, and that's secant, and the reciprocal of sine, which is cosecant. And we have those. And that's the end of some even problems for you to look at that are very much like your odd problems.